Okay. What else do we need to see from this maths paper? I'm looking at 4 and 5 and 6.
Why not B3, 4 to B?
Yeah, we can look at B. What's B3B? Ah, this thing. B3B. Okay. Will we have a look at this B3B? Yusuf, did you try this one?
No.
Oh, did you try anything here in the exam?
Yeah.
You skipped question 3.
Yeah.
Which ones did you skip then?
I can tell you which ones I did.
Okay.
I did B. I think I did B1, B2, and just B1 and B2.
You know you have to do more than that in the final exam, don't you? You have to do 4 questions in section B. All right.
4?
Yeah,
Out of
4.
5, they were 6, now they're 5.
There's 6.
They're 6, never mind.
You're thinking of physics.
Yeah.
But physics you have to do 3.
I forget. Yeah, you have to do 3, but you only have a choice from 5, not 6. Okay, so this one here is confirmed that the coordinates of P are 2, 16. So what you have going on here, you have a curve, y, Faisal, can you press the input button? I'll pull the projector down in a moment. Y equals 18 minus a half x squared. And this line here is y equals 20 minus 2x. And they want you to confirm that this point here where they meet is 216. How could you do that?
Equate the two equations.
You could, but it's only 2 marks, so it has to be not too difficult.
Is it the tangent and normal?
No.
Yeah, no, again, yeah, but
put the values in and you'll get the same.
Yeah, the easiest way to do it, because you already have the answer, is to substitute it in. So 20 minus 2 times 2 is 16. So that's true. And if you put that in here, 18 minus a half 2 squared is 18, 2 squared, which is 2, which is 16, which is also true. Is that okay? Yusuf, Wong, is okay? Yeah? Now, how to find this area? Oh, and yeah, and by the way, we actually know this point here and this point here. And we know this point now is 2. Right, you're right. Integrate with what, Andrew?
But we also know that that's 18.
Which one? The height? Yeah.
You don't need this.
It's good to know these things. Okay, so what do we have to integrate then?
Integrate from 2 to 10 and then subtract. Or subtract and then integrate. Or integrate 1 and then find the area of the triangle and subtract.
Okay.
Oh yeah, Steve, I have a question.
Okay, but first, answer me this. What do I do? Integrate from 2 to 10, and what should I integrate?
Top minus bottom.
Yeah. So in this case, that would be 20 minus 2x.
Minus 18 minus half x squared.
So the problem has just become solving this. A half x squared minus 2x plus 2.
Yeah.
Which I won't well, do you need me to continue? This is just a quadratic now. And this, believe it or not, is 6 marks. 6 dang marks.
1 sec, I have a question.
Yeah.
I don't understand this subtraction.
Top minus bottom.
Top curve minus bottom curve gives you the area in between the curves.
What?
Top curve, which is the line, minus the bottom curve, which is the quadratic.
So why don't we use the point 6 and 10?
We did use the point 6.
No, we used
Oh,
2.
sorry.
Because the area, Andrew.
Wait a second.
Yeah, because the area goes up to 2.
They meet at point B, right?
Yes.
Andrew might be onto something.
And the point B, you know the coordinates of point B.
Indeed.
No! Stop! Andrew's right. Our numbers aren't correct for 2 and 10.
No, they are.
They are
They
not.
meet at P, so the area starts from under.
Please, okay.
Okay,
No,
okay.
it's not
Okay.
6.
I know what I'm doing. So please listen to me.
Does his name sound like Storane to you?
What?
Not Storane, Stephen.
Limits are 2 to 6.
No, listen. Liz! What if maybe that's wrong? Okay, maybe I'm wrong. But let's just double check. No, you see, I don't like this undermining behaviour. Please, just listen. If I'm wrong, that's fine. At the very least, we'll all have a better understanding of double checking if the limits are right. So there is nothing lost here, only gained. Now, the reason I'm a bit suspicious of the limits, I'm happy with this one. This one I'm happy with. I think we can all agree we have to start at 2. But what's maybe not clear here is that the curve is continuing down. And if we stop at, for example, 10,
To take the area under as well.
yes,
Told you.
yeah, I think you owe someone an apology here.
Sorry.
Yeah, that's okay. So, we can do this, but we would need to cut off this piece here from our answer because we have too much. So, what would be the easiest way to cut this off?
Stop. That's it.
But if we stop it at 6, then we'd have to include this piece, which again is fine. So, I'll give you the choice. Do you want to do this as take too much and cut off the extra, or take too little and add on the extra?
No, take little and then add, because it's a triangle.
You
it's
prefer
easier.
to add on? Okay.
Why can't you use different limits?
And then you'll have to subtract.
Hmm?
You can do.
You have? Yes?
Use a limit for a curve and then minus the limit for the other curve.
Use 210 for the straight line, 26 for
Yeah.
the...
Yes, then that you can do as well. Yeah, you can look at this as like 2 shapes and you cut one shape from the other. You have several options here. And let's not forget one of these shapes is a triangle, so you don't even have to integrate as well. So you could look at the triangle minus the curve. Let's go with... Two to 6, and we just need to add on this little triangle piece here, because 2 to 6 would give us this much. Yes? So how big is this triangle's base?
4.
Yeah, so half the base is 2, and do we have the height of the triangle? We can have it. If we put 6 into the formula, we can get the height here. 20 minus 2 times 6, that's 8, isn't it? 20 minus 12. So a half of 4 is 2, 2 times 8 is 16. So if we just add 16 to the answer, then we fixed it. Yeah.
What about
Huh?
what about the part above the triangle that's also above the curve?
When I integrate from 2 to 6, it gives me this area.
Yeah, that's the integration for the line, for the straight.
Between the line and the curve.
So you minus them off.
But minus them still. And then we just got this triangular shape area here and just added it on. Now that's only one of 3 or 4 ways to look at this. It's probably the easiest one, I think. Okay, so it's still good for 6 marks, I think, but as you can see, this is why you double check your work before the end of the exam, if you have time. Okay.
I have a question, if you can answer it quickly.
Yes?
Sometimes the limits change and I don't understand
Yeah,
why.
yes. In section A questions, they flip it or do something to it. I don't know. I saw a question like that and I was confused.
In this paper,
No, not this
No.
paper, but I've done like many, and I know how to, what,
Is the method integration by substitution?
Yeah, I think so.
Yes, possibly, because there is, you see, I do it differently in class. I'll give you a simple example to demonstrate the difference in the two methods, okay? So let's say I wanted to integrate something like, I need to pick something not too difficult.
EX.
2x ex squared 0, 1 dx. This is my way of doing it. You make u equal to x squared, du dx equals 2x, dx equals du over 2x. So this becomes integrate 2x eu du over 2x. Yeah, they cancel, and you're left with eu du, which is eu, which is x squared, and then we put in the limits. Okay, that, you don't need to write that down, that's just the usual story. But now maybe you want to write this down. This is the way you can do it by changing the limits. 0 to 1, 2x ex squared dx, u equals x squared, du dx equals 2x. So far it looks the same. dx equals du over 2x. So once again this becomes integrate 2x eu du over 2x. And this is where it changes. So what I would do is change my u back to x. But they don't. They leave it as eu, and instead of changing the u back to x, like I would do, they change the limits, which are in terms of x, into u. So technically these limits are x equals 0 and x equals 1. And what they do is they change them into u's. So if x is 1 and 0, actually in this case it's kind of a silly one because it doesn't change, so I'm going to change it to 4 or something. So in this case the u would be 0 and 16. This corresponds to an x of value 4, and this corresponds to an x of value 0 by using this substitution. So it's just a different way of doing it. Most books do it this way, but I often find,
It's an extra stuff.
well, no, because you could say I have an extra step as well, because I would have to change this u back to x. However, the reason I prefer doing it my way is because if the question didn't have limits, you would have to change it back to x anyways. So rather than teaching students two ways to do it, if I just show them this one way, it works for both limits and no limits. So this is what you probably were seeing in the marking scheme, where the limits suddenly changed for some reason.
but like they would like note that 1 mark for changing limits.
Yeah, and for your method, if you were doing it my way, I would give that 1 mark for changing the u back to x.
But I'm sorry, could you just like show us the next step? Just
Oh yeah, so the next step will be E16 minus E0. Which is the final step.
so these limits here are 4 and 0.
The x was 4 and 0, and they were changed into u's. Originally in the question was a 4 and a 0, which became a 0 and a 16 by using this. Okay, good. So I'm glad you noticed that then. It means you're actually reading past papers. It's reassuring to me. I don't have to worry this weekend. A little bit. Look, I have in-laws coming to stay next week. I have enough to worry about. I don't need to worry about your exam as well.
Good luck.
I know.
You settled the house?
I'll finish it this weekend. Do you know, like your study?
Your neighbors settled their house?
Oh no. Although it got a little bit better because at least they put a cover up in front of their window, so I don't have to look in and see their front room every time I come home. but their pile of garbage is growing slowly by the day in the front garden. And then they put their bin out, and then my wife said to me yesterday, do you think they're just trying to get rid of all their garbage bit by bit by putting it in their bin? I'm like, that will take months. But it might be true. And then they were cleaning their car again yesterday. So when I got home, she said, I don't know if I should tell you this, but they were cleaning their car again. I'm like, how long? 3 hours. Why not clean your garden? Polish neighbours, what you gonna do?
What?
What?
Because like when we play video games,
Yes.
there's a lot of Polish people.
Yes.
They're always,
Everyone hates them.
yeah, they're the most hated gamers.
I have.
It's yeah, he's big into his
It's a stereotype.
Xbox One. And
But it's not just on PCs.
No. And he plays a lot of Polish music. Well, I think it's Polish because I can't understand the lyrics, but there's a lot of
German music.
Could be Swedish.
it could be, yeah.
They speak German and Polish.
But culturally, it's quite interesting because I'm starting to notice that Polish men are much noisier than Polish women.
Aren't all men much noisier than?
No.
Not necessarily. I would just think you would hear Irish women screaming if they were angry.
This one time, it was we went out at night to a
Yes,
club,
and I'd be willing to believe you could hear
and then
both Irish men and women
no,
shouting.
we're walking. It was me and Yahya, and then this woman, she looked really nice, and then suddenly she burped so loud, uncontrollably. I was like, whoa! Then everyone heard me, and then I felt awkward because like I shouldn't be doing this, but she shouldn't be doing this as well. It just came out of nowhere. Whoa!
Culturally, women probably don't burp in public back home where you.
No one burps in public.
Men or women.
But
Yeah.
like she looked so good. She didn't have to ruin her image in front of me.
Yeah. No, I notice Polish women are quite quiet when they're at home or they're out. And they're not very loud. Whereas Polish men, I think it's also because they're speaking in Polish and it's loud. It sounds even louder. You know what I mean? It's like I don't know what you're saying. You could be shouting at each other. I don't know. But they could be saying, "How are you? Nice day, isn't it?" But in Polish, I'm like, "What are you doing?" I don't know. Okay, B4 then. Do we need to see it or not?
Can you give us the marks first?
Okay, it's probably synchronized now. Let me deactivate the screen.
Do you also have the semester one?
I have everything. Sorry, Yusuf. Dropbox, as you can see here, is still synchronizing. I can't help it.
Give it a hit.
No, it's not. It's not with power.
Power solves everything.
Do you need help?
No, it's just I'm worried about
You
breaking
graduated
into the-
engineering. Engineer this.
See, power solves everything. Indexing.
What does it
What does it mean? What happens if I click?
Nothing, you'll just open up Dropbox, but the files haven't been synchronized yet. Sorry, you'll have to continue waiting. Okay, B4,
before me?
B4,
B.
B.
It's before me.
Give us a few more crisps, please. Thank you.
I'm sorry.
What?
You go from this to your parents-in-law. How unlucky.
Yeah, tough week ahead. Then also next week, my landlord, when I left, wouldn't give me the deposit back. So I have the case next week.
What would you give you your deposit back?
He says like he has to clean the house. I'm like, So that cost you €1,300? So I said, that's fine, just give me a receipt then. Then he stopped talking to me. So that's next week as well. So that's the day before the parents arrive. And then I had the pleasure of correcting your exam in between these days. Okay.
Andrew, watch Mrs. Brown. Seriously, watch it.
I think you'll like it.
You'll love it. It's an Irish comedy show. It's like, you know this, what's that name?
It's dirty humour, the type that you're into.
Dirty, dark humor.
Dark humor?
Yes, little bit. This American guy is always dressed up as a woman, an old woman. The
American
dude.
guy, he's Irish.
No, I know, but the American version of it.
There's an American version of it.
It's the same concept. This
Okay.
guy, he's the actor and
Okay.
all the parts, and he's the old woman.
Irish culture.
Yeah.
Right.
Fingers.
Okay. Now, Juan, you were asking me for this one. So the first part is, on a separate diagram, draw the following transformations. So what does the y equal fx plus 2 do?
Wow.
Yeah. So, I don't think I have to redraw it, but all these points, you have to move them
What about
up.
the x-axis?
Every every y value gets added.
Yeah, but
Two.
what about the x-axis?
What do you mean?
So if it goes up, the x-axis will change.
No.
The x point. Yeah.
Oh yes, no, I understand what you mean. The root will be different, but they don't want you to draw the root. Just
You need to draw the where the curve crosses the x-axis and the axis.
oh, son of a gun.
Only for streaming.
Yeah, that stinks.
Yeah, I think you should skip that question.
But anyways, no, it's a good question, but it stinks. So, anyways, you're happy with all these points just
Yeah.
moving up. The y value, you increase it by adding 2 to it. Okay? Andrew, that's okay? Yeah. But the tricky part is, in the new diagram, where does it now cross the axis? Now, it's not as bad, or maybe it is as bad. No, it's not as bad as you think. Because if this is the formula, in the old diagram, what were the roots here? They were -6 and 2. So you still need this to be -6 and 2. Except now you have x plus 2 equals -6 and x plus 2 equals 2. So the new roots will be -8 and 0. Yeah.
-8.
Yeah.
It doesn't make sense.
Yeah, because what's going to happen if you can picture this moving up?
Yeah.
Because one of the roots is 0, one of them will be at the origin and one of them will be at -8. So do you see here, I think what happens is when this moves up, this will be one of the roots, and then when this one moves,
Maybe less than -6 if it's more.
yeah, so it is. It might be on something.
Nothing is wrong.
That's it, what does it say?
Yeah, mine now. -6 and 0. -4 and -5, that's the way.
You know what I'd have to do? I'd have to graph this in the program, and then we could see it a bit better. Okay. Do you need me to continue it, or get the idea now?
And for 2,
Yeah, the nice thing about that is the roots don't change, because whatever made fx 0 will still make 2fx 0. So the roots stay the same, and all the y values multiplied by 2.
Ah, okay.
That part is easier than the first part, but bizarrely, same marks. Go figure.
Could you give us an example of an even function?
You give me an example of an even function. What's an even number?
Yes.
X squared.
Look.
That's it?
I have it written down, odd and even. But like it's fading out. And B3 and visa and odd and even. And I made a mark for
And it's
every
good
time.
to see you have the important things on your arm.
How
Visa. Talk to the parents. Odd and even function.
And then every time I
Yes.
Oh, we're
You
gonna
don't even know why.
get distracted here and my leg as well. Do you want to see my leg?
Oh, thank you.
Okay.
What do you
Wait.
want to know about odd and even?
Yeah, what are odd and even? As simple as that. Very simple question.
Yeah, yeah.
One.
Yeah, that's an entire lesson.
No, but like,
Google my YouTube channel. Odd and even. It's an entire lesson.
no, like,
Odd, 1, 3, 5.
No,
Those
no,
are numbers,
odd
not
and even
functions.
numbers.
Function.
Odd and even functions
but
are
like,
different.
what's the main difference between odd and even? That's
No,
all
I am not making up for your sleepiness in class.
No, it's not about that. Because I got a question. I solved it, but I solved it wrong.
I don't believe you.
No,
You're
seriously.
so full of BS
No,
sometimes.
seriously.
I
No,
don't
I'm
believe you.
serious. The question was, is this
mean,
an
that's
odd
not-
or even function? I said odd, turned out to be even.
We
Very
learned a
odd.
new word yesterday
What?
while we were doing our chemistry model.
What?
Deja vu.
Oh.
Again, that you've heard this BS somewhere before.
No, it's not a feeling, it's a fact. I know I have. I will simply tell you the definition difference between
Yes,
odd and
yes.
even. Anything more than that, you have to research yourself because you were asleep in class.
Yeah,
Or you were looking at Goku on your phone or something. I don't know.
female version of course.
Fine, fine. what rule number is that on the internet? The female version is
Oh,
something.
no, please.
What?
You only find that on the dark web.
Okay. Oh, it's like that, is it? Right.
You need a VPN.
Okay. Right, this is an even function. If f of minus x is still equal to f of x, we call the function even. Example.
Square.
Square, yeah. If, however, f of minus x causes the function to only change its sign, e.g. cubed, then we call it an odd function.
That's it. Okay. Negative sign and even does not change the
I'm
answer.
sorry, definition is said, all I give you.
Yeah.
Maybe one of those guys can help you.
Nice.
50-50.
That's it.
Yeah, that's it.
Nice. See, you wanted me to open a YouTube and search and wait 30 minutes just to find the video.
But you're forgetting my view count will go up by 1 for that video.
I'll open 3
Think
upload
about
videos
that.
right now.
Even D.
D. Yes, great. Great question. Let's do D now. Andrew, what mode should your calculator be in?
Oh, degree mode.
Please activate radian mode.
Radian?
No, yeah, because it's quite obvious.
Oh yeah, radian.
You know what I do?
What?
I never use radian.
Wait, sorry.
And then I convert from
Same
Angus to
by
radian.
that.
Better.
No, don't do this.
Hater.
Don't.
Hater, I swear, hater. You hate my circle method, you hate the way I do my things, you hate the way I walk, you hate the way I talk.
Don't forget the way you look.
Maybe it's only you, because everyone else loves the sugar.
Yeah, hang on, let me just send a quick text there to the right. So, on a scale of 1 to 10, how much do you like Faisal? Oh,
No. How good does Faisal look? That's a different question.
That's true, that is a different question. You think, although you might annoy her, she might appreciate the look.
Of course.
Mm.
Yeah.
We'll see.
Stephen, when should I use radians and when should I use degrees?
It's very simple. Very,
Always
very
use
simple.
degrees.
No! It's very simple. Don't listen to them losers. You always use radians unless something in the question is using degrees. So your question is backwards. You shouldn't be saying, when do I use radians? In fact, you should be saying, when do I use degrees? So the default mode is radians for everything in maths and physics, unless you see a degree symbol in the question.
But then, like, for example, in like the physics, the first question, it's always about the vectors, but there's no degree or anything.
Exactly. So it's legit to give your answer in radians.
When do you use radiating?
But then it's the wrong answer. Like,
No, it's not. It's just in a different unit. You could say, if for example, the answer was 45 degrees, and you gave your answer as pi over 4 radians, full marks. Yeah. So if you want to play it safe, always use radians, unless the question is using degrees.
So when do you have the chance to use radiating physics?
When do we what?
When do you use radiating physics?
When do you use
Yeah.
In the simple harmonic
chapter-
yes, simple harmonic motion and circular motion equations only work in radians.
Really?
Yeah.
Because it has pi.
Yeah, like the sine omega t formulas.
wait, so if I write pi in degree mode, that's a wrong
Yeah.
identity.
Yeah.
So-
No, I mean it shouldn't be. There shouldn't be. If you type in an angle using pi and you're calculating in degree mode, you're probably doing something wrong. I mean, technically, there's nothing mathematically wrong with that, but just because the way questions are constructed, it's probably you doing something wrong. Okay, D is what you wanted to see. Nice question. Does anybody know what to do here?
You have a close. Wait, no. Never mind.
Yeah,
Sine
take that
times
back.
cos equal.
Here, use your hexagon.
No, there's no hexagon.
Yeah, yeah. Where's your hexagon now, huh?
Isn't this like compound angles or double angles, something like that?
Something like that.
Yes,
Something to do with sine and cos.
Oh.
Right. You have to integrate.
you have to write it in another form by using,
Double angle.
yes, I'm getting the form now. Yeah, right? No?
I'll help you a little bit.
To, yeah.
It's, yes.
Then once
You
you
do
come
it
into
on the
it, what's
inside, you do it
Uh,
opposite on the outside.
You use the sine A plus,
This is a cosine.
There's an easier way. You could! Yusuf!
yeah.
You could! But there's an easier way for this one. What is
sine 2A.
Yeah.
It's not in the
I'm
hexagon.
thinking maybe I can find something.
What's the hexagon?
No,
No, no, no,
Don't look
don't.
into it,
You'll
you
get
might
sick.
get sick.
You'll get sick.
The hexagon is evil. Evil, I tell you.
Oh.
Right.
This hexagon is booty.
Now, are we clear with this now? We use the double angle formula to change 2 sine theta cos theta into sine 2 theta. Yes? That's it's in the formula book, I think.
Yeah.
It's one of the trig rules.
But
You can,
he added the half and the 2.
yeah,
Yeah.
half, you can move the half.
No, I can't.
He added the 2.
I added the 2
Yeah.
and the half.
If he do,
And then you remove the 2. So you remove
no, he
the-
didn't.
No, I replaced.
Oh, okay, yeah.
I replaced all of this with this. Yeah. Now this integrates to a half cos quarter cos 2 theta, and then we just have two limits and we're done. You know, and that's really not so bad for 4 marks if you spot that you require the double angle formula here.
You got the cos 2 theta by the
Integrate.
by substitution. U equals.
Yeah, technically u equals 2 theta.
Couldn't we just do this without using this rule?
How would you do it?
Like integrating?
But how? Using what method?
You have to use substitution or
Can
The
use, yeah,
by parts?
By parts, correct. However, the question was quite clear here. It said, by writing sine and cos as a single function, evaluate. True. By parts would probably give you the answer too. And in fact, I think a substitution as well might work. Yes, actually, if you said u equals sine theta, it will get the answer as well. So there's at least 3 ways I can think of doing this, but there's only one that they wanted here. Is that okay, Juan? Yeah. 5. The A part is vectors. Ooh, nice. 6 marks. Oh, this vectors question is, well, at least part 1, 2, and 3 is nice. Part 4 might be a bit tricky. Will I do this vectors question? Yeah. Yes.
If you want to.
Are you even listening?
Yeah, the vectors question, yeah.
Did it synchronize yet? Let's see.
It's been almost an hour.
Yeah. It's
Dun 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 dun. Synchronized. Okay. So.